Okay. We're going to have a little chat about how to do transformations of different types of functions that we did in Year 11 in Units 1 and Unit 2. We're going to start off by looking at the quadratic function, looking at the parabola. As you can see here, this is your basic parabola, y equals x squared. It's a concave up parabola. It's got a vertex here at the origin. This is its minimum turning point. In Desmos, all I've done over here is add in these sliders where A represents the coefficient outside and H and K, which are going to do different things. Okay, but we'll start with A and show you what A does. If we start to increase this value of A, then what we've got is a vertical dilation of scale factor 2. What that means is whatever the y coordinate used to be here, it used to be 1, it's been multiplied by 2, and it's gone up to 2. Okay. This here, it was 4, it's been multiplied by 2, and as you can see, it's gone up to 8. Okay, so that is a vertical dilation of scale factor 2. So whatever this value of A is a vertical dilation of scale factor away from the x-axis. And as you can see, as A gets bigger, the gradient of the function gets steeper. And as A is between 1 and 0, it starts to become shallower than the actual function, not quite as steep. Okay, and as A becomes negative, what it's now doing is reflecting it in the x-axis. Okay, and then we have vertical dilation of scale factor, let's say -2. So that basically just means we've taken what the y coordinate is, we've reflected it in the x-axis down to here, and then we have translated it, so we've dilated it by a scale factor of 2 from there. So it ends up down here. Okay, so that is the vertical dilation. Let's take it back. Okay, these values of h and k, what they do is translate the parabola into different places. This is your horizontal translation. This has moved it 2 units to the right. This is the equation y equals x minus 2 all squared. This is the translation of 2 units to the right. Okay, and as we take this over to the other side, you can say we've moved it to the left. Okay, we've translated it to the left, and this would be y equals x plus 5 all squared. Okay, so this value of h in here basically translates the vertex left and right in a horizontal direction, and then this value k at the end is the vertical translation. We're just going again up and down like so. So you can figure out where the vertex is at any particular point if it's in this format. Okay. Now, what can be done with quadratics in the parabola can also be done with your higher order polynomial functions as well. So here we've got a cubic function. As you can see with the cubic function, here's your basic cubic function. This has got a point of inflection here, where we are going from a concave down shape to a concave up shape. Okay. And again, this value A, as we increase this value A, then what we're doing is a vertical dilation of scale factor, whatever that is. Okay, it's taking, let's move it up to 3 here. It's taking what this was and it's multiplying it by 3. So the y coordinate was 1. It's times it by 3. It's moving up to there. Okay. So the bigger this value of A, the steeper the gradient of your function is going to get. And then likewise, if it starts to become negative, then we'll start to flip it over in the other direction. Okay, so changing this value of A can change the steepness of the function at any particular point because it's dilating it away from the axis. Okay. Let's go back to A is equal to 1. And then again, H and K, all we're doing is moving H and K. This translates the point of inflection left and right, like so, and then up and down, like so. Okay, and you can do this pretty much with every single type of polynomial. If you do it with a quartic, you just need to make that to the power of 4, a quintic, to the power of 5, etc., etc. Okay, but the other thing that we need to be able to have a little chat about and remember is how to translate the trigonometric functions, sine and cos, around as well. We did this a little bit in Unit 2, but we'll just touch on it again. This value A that's outside, if we change this value of A, then what we are doing is we're doing a vertical dilation of scale factor, whatever that is, right? This is a vertical dilation scale factor 3. That means it's taking whatever this coordinate is and it's challenging it by 3. It's taking it up to there. That's the y coordinate. These x-intercepts don't change because the y coordinate of the x-intercepts is 0. And as we start to make a negative, and it reflects on the x-axis. So, okay. One thing we probably didn't touch on is this value b here. What this does is this is another dilation, but this is in the horizontal direction. And this b value changes the period, right? So what this is a scale factor, horizontal dilation scale factor of half. It's taken this value here, which was at pi, and it's halved it, and it's moved it to pi on 2. Right? It's taken this value here, which was at 2 pi, and it's halved it, and it's taken it to here, which is pi, right? So whatever this value is here, b is equal to, we are going to have a horizontal dilation of the scale factor of the reciprocal of that, okay? So the reciprocal is 1 divided by, this has a horizontal dilation of scale factor of half. Then we got this h value here, which again does exactly the same thing as it did before. This is your horizontal translation. Yeah, this is moving it left and right. Okay, and then this value k at the end is your vertical translation. And this is moving it up and down. Okay, so there is some basic reminders about transformations of different types of functions that we learned in year 11. Okay.